Hi, everyone, and welcome to the third webinar in our virtual classroom series. We've already talked about upgrading, but today we'll focus on the functionality that makes it possible to upgrade without worrying.
Nobody wants unexpected surprises when they upgrade. So let me ask you this. What is your biggest fear? Is it coming to work Monday morning after that big production upgrade?
Oh, Daniel, no fear anymore. Seriously. Today, we will dig down into our toolbox and explain a straightforward approach to ensure performance stability, regardless if you upgrade or migrate. We will talk about parameters, statistics, tuning features, and a lot more, even including secret underscores. So let's start. Let's start off with tuning. So Roy is our Vice President for database upgrades for utilities, which includes Data Pump, SQL Loader, and for patching, which covers Data Patch. I work for Roy for a very long time, and we both cover customer projects all over the world. So working with Roy is great fun, and traveling with Roy is even more fun. So Roy is based on the East Coast of the United States, and he is with Oracle, I don't know, more than 25, 30 years? Oh, very long time, actually. You can follow Roy on Twitter. You find his Twitter handle here on the slide.
This is Mike Dietrich, Distinguished Product Manager. He has been with Oracle for ages and has served in multiple parts of the organization. For a while now, he has been the go-to guy on upgrades and migration. His blog is a must-read and a real treasure chest of tips and tricks and everything you need to know about Oracle Database.
Well, and you just heard from Daniel, so let me introduce him. While Daniel hasn't been at Oracle for ages, and Daniel, I think we'll have to have a talk about that terminology there, since I've been with Oracle just a little longer than Mike, he has established himself as an expert in cloud migrations and database upgrades. And he has a real knack for making really technical information very understandable and accessible. So you'll find that Daniel's blog is really useful, and he's another Oracle expert that you should follow on Twitter. Well, now that we've got the introductions done, let's get on with the webinar.
Hi, here we are again. A few organizational things up front. So at first, the slides. While I'm talking, the slides are already on the upgrade blog. mikedietrich.com/slides. Go to Web Seminar 2021 and find today's presentation as PDF already uploaded. Second, the video. The seminar will be recorded, and we will make the video recording available a few days after today's seminar. Also go to the upgrade blog, mikedietrich.com/videos, and find the link there as soon as it is available. In addition, you will receive also an email for the seminar, and the email will contain also the link to the video recording. Feel free to share it with colleagues, teammates, family, and friends. Third, questions. We try to answer all your questions during the seminar, but please use the Q&A. Don't use the chat. Only the Q&A makes it easier for you and makes it easier for us as well. Fourth, we will do a break in between. So after approximately 1 hour, we'll do a 5-minute break. During the break, we will broadcast again the link to the videos and the previous recordings. As soon as the seminar is over, we will do the same thing while trying to catch up on the remaining questions. And last but not least, the seminar gets recorded and broadcasted in HD. If you have any sort of resolution issues or blank screens, please just disconnect from Zoom and connect again. The link still works again. Try that, please. And now it's time to start. Let's go into details.
In the previous webinar in this series, we introduced you to this high-level roadmap for a successful database upgrade, being on the right version, getting the latest release update, and using auto upgrade effectively in your environment. This is the crucial fourth step of the database upgrade, which is ensuring good performance, because that upgrade doesn't end when the database upgrade itself is complete. It ends when your database is performing to expectation in that new environment. So the first thing we're going to talk about is some general high-level best practices around performance. And we would be remiss if we didn't start with parameters. We know that customers often want that key parameter that's going to make everything run fast and flawless. But really, our general recommendation is to use the defaults wherever possible. The fewer parameters that you set, the better, because the more you're running on the defaults, the more you're running in the environment in which we develop and test the database. So a very small number of parameters is generally your best bet to achieve good, stable, predictable database performance. You may want to set some parameters, even some undocumented ones, as we have here in this example, but we'll talk more about those as we go forward. What you don't want to do is use deprecated or desupported parameters if at all possible. Now, desupported parameters you can't use, and it's worth talking about the difference between those terms. A desupported parameter is one that is simply not allowed anymore. And if it's desupported, then when you go to start up your database, it will not start. We will give you a message that you have an unsupported parameter there. You'll have to remove it from your P file or your SP file. A deprecated parameter is one that we reserve the right to desupport at any time. And that desupport could come in the next release update, it could come in the next full release, or it could come many years down the line, depending on the conditions. One example of that was the secure case-sensitive password parameter, which was introduced in 11.1, deprecated in a succeeding release, and is being desupported. With underscore parameters, and especially underscore parameters and events, these are generally undocumented, and you want to use those very judiciously and only under the guidance of support if possible. Use as few undocumented parameters as possible and only use them for as long as they're truly needed. So if you go querying the $V parameter view and you find a bunch of undocumented parameters there, that's when you need to begin the work to make sure that you understand, first of all, why those parameters are there in your init file. And second, when can you get rid of them? Is a parameter added to address a bug that you experienced in a previous release that's now been fixed and thus should be removed? Is it there because an application is telling you to set it and maybe you need to check the documentation when you do that application upgrade? Whatever the reason, you want to make sure that you know why everything is set in your environment. Now, I mentioned applications, and every application from Oracle supplied ones like eBusiness Suite, Siebel, JD Edwards, or PeopleSoft to third parties like SAP might tell you to set certain parameters at certain values or based on system characteristics, and that's okay. The application gets to dictate your parameter settings for the database. But beyond that, you want to make sure that any parameters that you set have a comment in your init files so that in a couple of years, when you've forgotten why you did it, or when someone else is managing the database that you've configured, it's understandable when they look at the P file or the SP file to say, well, why is this parameter set, or why is it set to this non-default value? So you can set that comment when you're setting the parameter interactively, or of course you can do it when you create a P file, and then you can query that nicely, even out of SQL Plus, to find out what parameters were set for what reason in your environment. Now, when it comes to upgrade, kind of the king of all parameters is compatible. And it's worth talking about the compatible parameter and optimizer features enable when it comes to performance. Now, you might think that compatible will govern optimizer behavior, and that's a common misconception. Many customers think that if they leave compatible at 11.204, they won't see any query plan changes, for example. And actually, that's not true. The compatible parameter limits access to new features that cause changes to on-disk structures in the database. So what it does is it preserves your ability to fall back to that release, because then we will know that the contents of your data files could be understood by, say, 11.204 or 12.102. So when you think about features that are governed by compatible, it's going to be things that change the on-disk representation of the database, such as the multi-tenant architecture or long varchars in 12.1, long identifiers in 12.2, even going back to 11.1, secure file lobs were a different way of representing lobs on disk. What they won't affect, what the compatible parameter does not affect, is the optimizer. Now, the optimizer has its own parameter, optimizer features enable, which will affect the use of new optimizer features in the database. So every release, the optimizer team comes out with new and innovative ways to optimize your queries based on different join methods or different ways of decomposing queries and subqueries that can just make more effective use of either modern technology, like, say, persistent memory, or other features such as different types of partitioning. Now, again, people often misuse optimizer features enable, thinking that it will preserve every single query plan in the database and leave everything unchanged. And that is also not true. The optimizer features enable should be best treated as a diagnostic tool. If you run into query plan changes that you didn't expect, sure, try setting optimizer features enable back to that old release. And if the query goes back to what you wanted, then that's a sign that maybe you should open an SR with support so that you can delve into the particular optimizer features or other changes in the new release that might have affected that query plan. But if you're using optimizer features enable across the board, it's kind of like using a sledgehammer to kill a flea. It's a very blunt instrument when a more surgical instrument would probably do. So compatible is about on-disk structures, but other features are going to, or other parameters are really more about your memory usage, which of course can have a huge impact on your performance. So I'm going to let Mike talk about the most important memory parameters.
Automatic memory management, AMM. What does the documentation say? You can allow the Oracle database instance to automatically manage and tune memory for you. Sounds great. We speak about these two parameters, memory target and memory max target. And it sounds great, but don't use it. Yeah, we tell you, don't use these parameters. Why not? First of all, on Linux, no support for huge pages. Your machine has like 128 gig of memory, but you can't address the memory with huge pages. That's bad. Potentially, the PGA can rob the SGA, because now you tell the database, this isn't my SGA target and this is my PGA aggregate target. You tell the database, oh, this is the pool, and do what you think is best. It sounds fantastic, but in reality, this can lead to terrible situations where you do certain actions with your clients, and the clients allocate more and more PGA and request more and more PGA. And the database today is in a generous mood and gives the clients a lot of PGA. Unfortunately, then you start your normal operations, and now you need to load a lot of blocks in the SGA to do insert update deletes. And the database realizes, oops, the SGA is very small. I have given everything to the PGA. Not a great idea. Don't do that. There's also then, when we have that situation, a big overhead on resizing the memory portions. It's not like the database doing, okay, give me 10 gig. It's now an internal process of claiming back memory from the SGA, from the PGA gradually, or the other way around. Could be also the other way around. So it's a bad idea. And in addition, we use also different malloc calls in the kernel. So don't use this parameter. There are issues. There were always issues with that. There were customer SRs with this, and we don't see a benefit. Even when you use DBCA and you want to allocate now a lot of memory target, and it's still the standard setting, or it was for a long time the standard setting, the DBCA warns you and tells you, no, not possible. You can't allocate your memory here. Some platforms allow you that, but no, don't use it. The only possible use cases we could think of, if you really want to go into discussion with us, is for your ASM instance, because there you typically don't have a big SGA and the load is always very similar. And the second thing is for small, tiny little production databases. We don't say it's not working. We just say, oh, it gives you trouble. And we have seen for these tiny production databases, we have seen issues with upgrades when memory target was too small. So don't. Consult your database installation guide. That's it. Next topic, fixed control persistence. The idea of that strange wording with DBMS Optim bundle, a package in the database, is since a long time, we deliver behavior changing optimizer fixes with bundle patches. We already started doing this for 11.2 Exadata bundle patches and for 12.102 with the normal database, the non-engineered systems. Now in 12.2, it's the release updates and the release update revisions. And when such behavior changing optimizer fixes are included in a bundle patch, then they are turned off by default. Now you want to turn them on. And even more, you would like to apply the next RU maybe in April, and you would like to keep the settings from before persistent. And this is realized via the DBMS Optim bundle. So it's there for non-engineered systems since 12.102 April 2017 bundle patch. And there were a few cases where it disappeared and then it reappeared again. How do you use it? And why do you want to use it? So we roll out a lot of patches. For instance, here, this example with 1910. Set server output on. This is important because otherwise you don't see any output. And then exec DBMS Optim bundle, get bugs for bundle. Okay, now I get a long list here for 1910. So you get the bugs listed, and these are all potentially behavior changing optimizer fixes. And they have a fixed control associated with them. What do we do with that information? We can enable them, but, and this is one of the flaws of DBMS Optim bundle, we can enable only either all of them or keep all of them disabled. But I show you in a second or explain you in a second what you could do if you want to enable just a subset of them. But DBMS Optim bundle allows you only the everything at once approach. We say DBMS Optim bundle, enable Optim fixes, action on, yes, turn them on, scope both for memory and SB file. And the last setting, current setting precedence, yes by default means when you had, let's say, the October one already, the October RU for 19C, and you use DBMS Optim bundle, and now you go to the January one, and you call it again. And there was something disabled at will before. Even though you enabled a lot, but you disabled something at will because you decided, I don't want to have that, or you had an issue with this. Now, by default, this would give a conflict when you call the procedure here again. And by default, yes means your setting takes priority. So we don't create a conflict. We just don't enable that fix again. So we leave your current setting. If you would say no in this case, then you would give the new enabling priority, and you would override the disabled by default setting from before. So typically you do best with the yes, and there's not much you should think about that. Now the output of that procedure, when I call this, it tells me first, what is your current fixed control setting? Is there anything in my SP file? And it says none. Okay. In the second big block, it tells me now what it will set in my SP file. So all these settings here will be added to my SP file. And you may wonder about this :1. Typically :1 after the fix means it's enabled. But you see there's also :0, or in the middle pillar, you see at one case there's a :7. So :0 means it's disabled, and :7 here means there's a special setting for this fix. So it has different states. It's not just 0 and 1. In memory, below the third section, you see it's always 0 because nothing gets changed now in memory in my database right now. This is important to mention because we need a restart to take this effect here. And this is what we'll do now. We will have this long, oh my God, incredibly long and very hard to read long fixed control setting in the SP file after we used it, at least with a comment. That's good. But if you want now a control and you say, the first one, just let an example, the first one here, the 29331066, this is one you had an issue with. DBMS Optim bundle doesn't allow you that granular setting. So you would now have to edit the fixed control setting and switch that one manually to 0. And now back to the precedence from before. Let's say we go to April. And in April, this is still there. And by default, it will still enable it again. Now it realizes, oh, you set it on purpose to 0. And by default, your 0 setting will be kept. Not bad. But you need a restart to take the effect here. It sounds good. It's helpful. It's just sometimes a bit, I would say, it had some tiny little flaws. So as I said before, in some cases, it appeared and disappeared again in the next bundle or in the next release. And especially for 1910, you need something. Unfortunately, when you want to use DBMS Optim bundle, when you never want to use it, ignore that. But when you want to use DBMS Optim bundle with 1910, you need that patch 3.18.62593. Because if you don't have that, and you check now, DBMS Optim bundle tells you only the 99 fixes. So it can't produce the output for 1910. The XML information hasn't been loaded into the database. And so you can't set the correct fixed control settings for 1910. But that's what we want. So need that patch, simple patch, doesn't require data patch. And then you go with this one. In addition, we are patching here. Yeah, we do the patching all the day. We love patching. So what you want, what you ask us for a long time is, okay, guys, I go to 1910, but what issues are known to Oracle? What one-off fixes do I need to apply on top? And I hope the one I mentioned before is in that list as well. I haven't checked that actually. Need to do it afterwards. This note here, it's just out for a few weeks. And Roy pushed very hard that we get this public. And everybody internally realized, oh yeah, this is really important. Let's tell you what we know is available via one-off fixes on top of a given RU. And I think right now or soon we get an extra column where we tell you when, in which RU the fix is fixed. What you do, you see the buttons here in that screenshot. Let's say you are live on 19.8 and you know you have to stay a little bit longer on 19.8 for whatever reason. Then you click on 19.8 and you get a list of 24 fixes. 24 issues on top. We fixed already in newer RUs, but you need to apply the one-offs. Or you may need. It's not forcing you, but we would like to tell you about these issues, which are known to us to prevent that you hit the same issues. Also, when you hit 1910 here, you see there are still 7 issues listed for 1910. When the column comes in telling you, oh, they will be fixed in the next one, all is good. Then it's even better. So take this into account, please. And now on with Daniel.
Wow, interesting. The next topic is statistics. We all love statistics, and we will talk a lot about statistics today because it's really important for a well-operating database. The first thing that we will talk about is dictionary statistics. Dictionary statistics are on the schema sys and other Oracle-maintained schemas like system and XDB. Like with any other statistics, the automatic maintenance task will ensure that you have good statistics on your dictionary. However, I know that some of you prefer to disable the automatic maintenance task and gather statistics on your own. If you do that, you can change the automatic maintenance task to only work on the dictionary stats by changing the auto stats target to Oracle. Then you can still have the maintenance task gather good statistics in your dictionary, and you can maintain other statistics yourself. So if the automatic maintenance task takes care of dictionary statistics, should you worry? And the answer is yes. There are some situations where you manually need to gather or refresh the dictionary statistics. Before and after upgrade, we recommend that you gather dictionary statistics. If you use auto upgrade, it'll take care of it for you. But we recommend that you at least gather dictionary stats in advance so you can save some downtime. Also, when we talk about logical migrations, this is when you use data pump or transportable table spaces to migrate. We recommend that you gather dictionary statistics on the source database right before the export, and again on the target database immediately after the import. When you import a lot of data into the database, the dictionary gets populated with brand new information about all those objects. And that's why we need to gather dictionary statistics, so the rest of the migration won't be affected by bad stats in the dictionary. And you might also consider to gather dictionary stats after a major application upgrade. The new version of the application might have hundreds or thousands of new objects in the database, so it could be a good time to regather statistics. If you look in the documentation, you'll find a procedure called gather dictionary stats. And it might sound like the best way to gather statistics on your dictionary. But actually, our recommendation is to gather on the sys and system schema instead. Why is that? Well, gather dictionary stats will by default work on all the Oracle maintained schemas, and we only want good stats during migration and upgrade on sys and system. That's normally enough. In addition, gather dictionary stats will use the staleness information to determine which objects where new stats are needed. We have often seen that that's not good enough, so our recommendation is simply to gather statistics on the sys and system schema entirely. And for your reference, we've included a little code snippet that will show you how to do it in a multi-tenant database in all of your containers. Next, we have fixed object statistics. If you look in the documentation, you won't find much about fixed object statistics. But in the upgrade guide, it says that after an upgrade, we strongly recommend that you regather fixed object statistics after you've run a representative workload on your database. So this means that you should never do it right after an upgrade. Why is that? Well, let's see what fixed objects really are. It is those $X tables that you find in your database. But they aren't really tables, they are memory structures. And for instance, you can find $BH, which represents the buffer cache. During a database upgrade, the database is restarted multiple times. This also means that the buffer cache is flushed and completely empty. So if you gather fixed object statistics right after the upgrade, you will gather statistics on an empty buffer cache. If you then start to use the database, you will warm up the buffer cache, and all of a sudden it might grow and contain a lot of objects. Now the statistics are no longer good. You had statistics on an empty buffer cache, and now you have a full buffer cache. That's why it's so important that you only gather fixed object stats on a warmed up database. So take a minute and ask yourself, do you remember this? Do you go back to every database you upgrade after a while and gather fixed object statistics? If not, DBMS Scheduler to the rescue. First, you create a SQL script, which creates a scheduler job. That scheduler job will fire in 7 days from now, and it'll gather fixed object statistics for you. And you can even set the auto drop property to true, so the job is automatically removed when it completes. You can then create a shell script which executes catconpl and to execute that SQL script in all of your containers. And if you're using auto upgrade, you can use an after action to get auto upgrade to execute the shell script for you. Are there other situations where it might be useful to gather fixed object statistics? Well, after major application upgrades, it can be a good idea for the reasons we discussed with dictionary statistics. When you start to use new functionality in the database, a new component, it's also a good time. New functionality in the database probably have some new supporting memory structures, and we need statistics on those. And when you do major database configuration changes, like adding more CPU or increasing the instance memory, it can also be a good idea to gather fixed object statistics. But for all the cases, it is super important that you don't do it on the database immediately after a restart. You have to ensure that the database is warmed up, that you have run a representative workload on the database. So here's a good SQL that you can use to determine whether or not you have good dictionary and fixed object statistics in your database. We will use the view CDB obstat operations and look for operations that are gather fixed object stats, gather dictionary stats where the target is either null, being everything, or system, or schema stats on system. And you can look for the records from the last 7 days. This will give you a good overview of the statistics operations in your database and help you to determine whether or not you need to regather some of them. And to show you the effect of having good statistics in your database, this is from a demo we did on a container database with 52 PDBs, running on a system with 32 cores. By gathering dictionary and fixed object statistics before the upgrade, auto upgrade didn't have to do it during the downtime, and we managed to save 12 minutes of the upgrade runtime. In addition, in our tiny hands-on lab, we compared the database upgrade runtime when we had no statistics and good statistics, and we got a 14% reduction in runtime. And on an Oracle EBS database, the reduction is even bigger because EBS puts in thousands of objects into the database. So by comparing no dictionary and fixed object stats to having the situation where they are good and accurate, there is really a dramatic reduction in the upgrade runtime. And this is an example of an SQL that is used during a database upgrade, and we compare the situation with no or stale stats and good stats. And as you can see, this is from a real support case. There is a dramatic reduction from almost 10 hours to only a few seconds. And the only thing we changed was to have good and proper dictionary statistics in the database. So more statistics to cover, but I need a break. So Roy, will you take it from here and talk about system stats?
Sure, Daniel, I'm happy to take over. So let's talk about these system statistics. Now, system statistics are one of the lesser known classes of statistics in the database. Most people think about stats on indexes and on tables, but system stats have been there for a while. And if you do know about them, it might be because of the tuning guide, where it gives you this kind of description, which makes them seem very appealing. It sounds like a really great idea to calibrate your query optimizer based on your particular hardware configuration. But to be honest, if you take the recommendations of our optimizer team, in most cases, you should be using the defaults in your system and not gathering system stats yourself. And that's true even when you have a pure data warehouse workload or you're running on Exadata. Unless you can really robustly test the effect of those system statistics, you should use the defaults. And the reason for that is that we've seen system statistics really skew things in ways that might be unexpected. So if you have done that yourself and you find that the system stats actually had a negative effect on your performance, one thing you could do is delete them. And when you delete system statistics, it doesn't just wipe out all system stats on your server. What it will do is it will return them to the defaults, which, as I mentioned earlier, are generally good for most environments. If you want references on this, you can get links from the Optimizer blog and the tuning guide. And I just want to give you one other piece of advice coming from our real-world performance team. if you've taken the real world performance courses, what you'll hear from them repeatedly is that things like system statistics can have a good effect on performance, but in literally every case where we have worked with customers and found that system statistics helped, the root cause was not system statistics. It was other types of statistics that were not being gathered properly. And once we had those table and index statistics gathered correctly, the system statistics were no longer needed. So again, the general advice here, use the defaults. Now, since Daniel gave me the microphone, I'm not going to give it up right away. We're going to talk about the Statistics Advisor as well. This is a feature that was added in 12.2. So if you're coming from 11.2, you might not have encountered it. If you've been on 12.2 or 18C, it's been running by default, and you may not have even known about it, but it's there. You might want to give it a try, because it can give you some good information about whether you've got statistics locked, how you're gathering them, whether you should be doing some things differently or somehow calibrating your maintenance jobs. However, it does have a side effect that it stores data in your sysocs table space. And sometimes that data can be quite expansive. So what you might want to do, especially if you're running 12.2 already and didn't realize that the advisor's been running every night, is you could query the $V sysocs occupants view to see how much space it's using, and it will really lay it out. You can find out whether it's using megabytes, hundreds of meg, or even in our case, gigabytes of data inside your sysocs table space. Now, sysocs is one of those things that just grows and grows. There's no way to shrink your sysocs table space, but if you've got this advisor data there and you don't really need it, you could at least free up space within sysocs for other uses like incremental statistics, AWR snapshots. But to do that, it's really a two-step process. The first thing you would do is disable the automatic statistics advisor job. In 21C, you can disable the auto task. That's a single command, very easy. It's not so easy in 19. Now, you could request a backport of this bug number, put it on your system, and then disable it just as you do in 21. I don't really recommend that because that backport, it's not part of the release updates. And that means that with every successive release update, you might need to get a new version of the patch, which is kind of a pain. There is a workaround of how you can do that, which is to simply set the advisor interval to be that maximum 2 billion plus seconds between running. And that means that it's really not going to run again in your lifetime. Now, once we've disabled it, that does not delete the advisor information from your sysocs table space. If you want to do that, if you want to purge those records from sysocs and give yourself some free space for other things to use, then you could refer to these two Moss notes about how to purge those records. So I think that's enough about statistics. Well, maybe just one more thing. Let's just talk about what to do with your stats history retention period. Now, stats history allows you to revert to old stats in those cases where you gather stats and suddenly something weird happens with your performance. You might want to revert to the previous stats that just before you gathered them. And that's fine. There might be occasions when you do that, and then you have to figure out why gathering stats on that particular table might have been a bad thing. That's okay. Revert to those old stats temporarily. But realistically, the default setting here is probably too large for the stats history retention, because this is something else that goes into your sysocs table space and takes up space. So what you would do here is we would suggest that you change the default retention period from the 31 days and put it down to maybe a week, 10 days, at most 2 weeks, because the odds of going back to month-old statistics in a volatile system and having them be useful are pretty low. So that's the last thing we're going to say about statistics. And now I'll hand you back over to Mike.
Testing. Next topic. Testing best practices. I hope we all agree we need to test. And when we receive emails, comments on a blog, phone calls, and somebody's telling us, I have an upgrade problem, help me. Or often it starts with, I have a customer with an upgrade problem. Then we know in 90 to 95% of all cases, it's not an upgrade problem. It's mostly a performance issue after upgrade. And sometimes not only one performance issue. In rare cases, it's also like an install or whatever issue, but performance, it's typically the top category for issues after you change something. And I guess this is also the reason why you are watching this seminar right now with us. There's exactly one way to mitigate that risk, and this only one way is testing. Now, as we work in reference projects with people out there, we see typical testing mistakes. And this is just an excerpt of what we see and what we saw out there. And we can just tell you here, don't do that or try to avoid this, no matter how big the constraints are. Only a subset of data used, artificially created data sets, outdated data from a year ago, or what makes me always smile, testing done on a laptop. We had that, believe me. Or we had like terabyte installations of HP in production and the testing was done on Linux. Yeah, it can work, but this is not ideal. I hope we all agree. No testing tools used, especially if you take some of the previous parts and then you have no testing environment, no testing tools, then it's bad. This is asking for trouble. And also no stale stats refresh, but we'll cover this today as well. The worst thing, real experts fix it after go live. Not cool, believe me. We had that. We had somebody at Open World on stage. I sent Roy to such a talk and he came back, and I saw Roy only twice in the last 13 years since we worked together, with a really strong neck and a red hat. And this was one of them because I sent him to a talk at OW. And he said this guy was on stage telling everybody that testing is just a waste of time and real experts fix it after go live. Yeah, you can try that. I wouldn't recommend that. Don't, please. And when you test, we work with customers globally. And in some countries, it's really a pattern that people want to reach test completeness. And then cycles takes 3 or 4 years until you can go live. Don't do that for a very simple reason. We always try to reach something like 80 to 90% test completeness. But reaching really the final 20 or 10%, you will put in the same amount, the same effort, the same resources, the same costs as you already put into the project to reach 80 or 90%. So test completeness, I wouldn't go for that. There's always a little bit of risk involved. And today's seminar is really meant to show you you can deal with this. We go to 80%, and still if something fails, we have the right things in place to fix that once we went live. But if we want to test, we need a test system. So we told you some typical mistakes, and now a few ideas on what we think is a great idea for setting up a proper test environment. So one of the things we like the most is snapshot standby databases. You have a physical standby and you convert it for a temporary amount of time into a snapshot standby. So it's now a read-write database. The cool thing is the logs will be still shipped. The only downside you have is you have a little increased RTO. So in case of you would need your standby now because of disasters happening on production, then the failover will take a little bit longer because the database has to be reconvert, go back to the restore point, and then apply all the logs. But redo apply is not slow. Redo apply usually is very fast. And so you may have a few extra minutes, but in exchange, you have a super cool test environment. Even auto upgrade can be very well used on our snapshot standby. Another option, which we cover actually in the seminar 6 of this series, hybrid data guard. So you build up your data guard, for instance, with ZDM, zero downtime migration, and you build it out in OCI in the cloud infrastructure. You can even create as many as you like. You can have several test incarnations. And we did this recently with a customer in the UK, and it works really so well. Pay as you go. Awesome. When you're done, you destroy it, no payments anymore. This is really, really cool. We will do this in a seminar we'll give soon in EMEA, where we show all the performance options and testing by using and leveraging the cloud for these cases when you don't have a proper test system in your environment. CloneDB, that's a tool or a scripting tool. Copy and write, use image copies of the data files stored on NFS. Delta is written locally. Very nice, very useful. Snapshot copy of PDBs, but this requires a compatible storage system. Or you could use CloneDB as well for this functionality, but then your source PDB has to be set read-only, or CloneDB sets it read-only. Then we have split mirror CloneDBs. This requires ASM and at least 18C, and it will be generating a point-in-time version of a PDB. And finally, on Exadata sparse snapshots. Here you can save a lot of space, actually, fast provision, and it supports most of the storage features as well. Then it's time for Daniel to take over.
Thanks, Mike. Now that we've found a test system, let's talk about how we can use that test system to take care of your statistics. First, optimize the statistics on your user objects. After upgrade to database 19c, should you delete the statistics and gather them again from scratch, or should you refresh the statistics? No, not necessarily. It's not required, and it's generally not recommended. But especially if you're upgrading from 11.2, there are changes made to the way that the database creates histograms. In such a situation, it might be beneficial to gather new statistics to benefit from the new histogram types. It might also be that you prefer to have the same new format of histograms in your entire database rather than having a mixed format. But it's generally not recommended. But if you decide to do so, here are some tips on how you can regather optimizer statistics as quickly as possible. The first option is to use concurrent statistics. When you enable that, the database will gather statistics on multiple objects at the same time. If you want it to become even faster, you can change the preference degree to auto degree. For really big tables, this will now enable the database to use parallel query when it gathers statistics on one specific table. But be advised, this will put more load on your CPUs. But if you want it to go even faster, you can combine the two, use concurrent and auto degree, and you can really use as much CPU as entirely possible. But be advised, this really can put a load on your system. If your database is the only database on that host, you probably don't care, you just want to gather statistics as fast as possible. But if you're sharing the resources with other databases, you don't want to be that noisy neighbor that steals all the CPU resources from the other databases. In such a situation, take care. In their pro tip in the lower right corner, there's a link to a blog post, a really interesting blog post by Nigel Bayliss, where he shows the effect of using and combining the various options for gathering optimizer statistics. But in some situations, when you have a really tight downtime window, you can't afford to regather statistics after the upgrade. What can you do? This brings me to the next topic, which is transporting statistics, where you can take a set of statistics from one database and import it into another database. You can do it on schema or table level, but you can also do it on database, dictionary, and fixed object statistics, but those three scenarios are rather rare. Typically, it's on table and schema. You can use it, for instance, if you want to have your production statistics imported into a test system. If your test system is empty or only has a subset of the data, you can still use it with your production statistics by moving them into your test system. Similar, you can use your production statistics for query tuning. If your developer needs to work on a special query, you can give him the production statistics into his little development database so we can work in a much more realistic scenario. This is the use case that I mentioned earlier, that you can import statistics after an upgrade if you don't have time to regather statistics. You can take statistics from your test system and get them into your production database, but you should only do this if your test database is 100% similar to your production database. The data should be the same, otherwise the statistics will be inaccurate. Similar, when you do migrations, you can get new fresh statistics into your migrated target database without regathering. Especially if you're doing character set migration, we strongly recommend that you delete your statistics and regather. But in a very narrow downtime window, that might not be possible. So you can take the statistics from a test database, a 100% similar test database, and move those into your production database to get new and fresh statistics. And finally, you can use DBMS stats as a way of transporting your statistics instead of using data pump. You will often find that using DBMS stats as a mean of exporting your statistics will be much faster than using data pump. So how does it work? In your source database, we have the data dictionary, and then we have our user data. And in this example, it's stored in a schema called sales app. The optimizer statistics are stored in the data dictionary. Next, to transport the statistics, first we create a staging table in our sales app schema. Now we can export statistics from the data dictionary in a binary format into a transportable format in the staging table in our sales app schema. The staging table is a regular heap table, so we can just export it with data pump. Now, on the target database, first we transfer the dump file. Then we can use data pump to import the staging table into our sales app schema. If you have network connectivity between the two databases, you can also do it directly over a network link. And then I import my statistics from the staging table into the data dictionary. I've prepared a small demo where we can see it in action. I'm exporting statistics from an 11204 database, and I'm importing into a 19C database. First, I'll create a schema and populate it with some data. I create my sales app schema, and I grant DBA. Obviously, don't grant DBA at home. Then I create a table, and I insert some rows. I also need an index. And now I'll gather statistics and see how they look. So gather table stats. And now my basic table statistics has been populated around 200,000 rows. In addition, I have column level statistics, number of distinct values, and histograms. And the index statistics have been populated as well. Now that I have my statistics, I can export them. I create a staging table and then export statistics from the data dictionary and into the staging table. Then I create a directory object that I'll use with data pump. And now I can export using data pump, connect as the sales app schema, and export my staging table. Whoops, there it is. Now on the target database, I'll create an empty schema, an empty sales app schema. I create the same table, but I use a predicate that ensures that no rows are put into the table. Then I create the same index and gather statistics. Now I have an empty tables. There are no rows in the table. And because I have no rows in the table, I will have no histograms. And luckily, my index statistics reports the same, 0 rows. Now it's time to import statistics from my source database. I create a directory object, and then I start data pump, connect as sales app, and import my staging table from the dump file. Now, back in the database, I try to import my staging table, but I get an error because the version is 11.204 and I'm now in a 19C database. So first I upgrade the staging table, and then I redo the import, and this time it succeeds. So let's look at the new statistics in my target database. Remember, it's an empty table, but the statistics tells me that there are around 200,000 rows in the table. When I look at the column statistics, I can see that even my histograms has been imported into the new database. The columns with 0, those columns are new columns in the 19C view or in the 19C table, and that's why there are no statistics for that. And my index statistics has been populated as well. So, easy, only a few commands allowed me to move my statistics from an older source database into a newer target database. The optimizer only uses statistics from the data dictionary. If you have statistics in a staging table, they won't be considered by the optimizer. By importing statistics, you mark the statistics on that table or those tables or indexes as current, as in not stale. So the next time the automatic maintenance task comes by and look at this table, it won't regather statistics because they are not stale. You can even transfer statistics from a lower release to a higher release, but in some situations you need to upgrade the staging table. And finally, if you're using incremental statistics, you should consider whether you also want to export the synopsises. If you don't export the synopsis information, the next time you gather statistics on that big partition tables, it'll have to scan all the partitions because the synopsises are not part of the new data dictionary.
Let's go on with our next topic, incremental statistics. And at first, a quick overview. So the feature got introduced in Oracle 11g, and more important, in 12.201 onwards, it got improved drastically. The idea of incremental stats is, if you have list or interval partitioning, that in order to update the global statistics, we don't have to revisit the existing statistics because we store the so-called synopsis in sysocs table space. So statistics collection with incremental stats in partition environments can be way more efficient and with less overhead. There are a few known pitfalls. One of the typical pitfalls is that the synopsis in releases before 12.2 could consume a lot of space. And when I say a lot of space, I can tell you that we've seen customer environments where the synopsis alone consume more than 1 terabyte of space in sysocs. Also keep in mind when you transport statistics with DBMS stats, synopsis by default are not included. So if you would like to include them, please use the extra call being available in DBMS stats. Now with 12.2, the feature got significantly improved with a new algorithm for the synopsis. But the new algorithm is not picked just by default. So we have to do a little bit. Now I would like to show you at first the concept of incremental stats and then show you the configuration steps we need to take. And at third, then explain what you should do when you upgrade to 19C. The concept, we see here an orders table with a few partitions for each data partition. Now, when we have incremental statistics on and we create new statistics, for each partition, we'll store statistics, but partition level stats. But in addition, we also take note, and this is called a synopsis in sysocs table space. With the information, the partition level stats, we can now calculate the global statistics for that table. So far, so good. But when the incremental stats are on and we add now a partition, now here the yellow partition for May 24th has no statistics, and we gather now statistics for this partition, and with the synopsis stored in sysaux table space, we can now calculate and refresh the global statistics for that table. Without incremental stats, we would have revisit all the existing partitions, but with incremental stats and the synopsis, we don't have to do that. This is the idea of incremental stats. What do we have to do? A few configuration steps. First of all, by default, incremental stats are not on. So you have to turn it on. Now you could turn it on a database level. We disrecommend that. We recommend that you turn it on a per table level. This is what we do here in the first call, set table prefs for the orders table incremental true. A must do is that you enable also the staleness, the incremental staleness. Because by default, if I had just, let's say we changed an order given a week ago in one of the existing partitions, then without incremental staleness, the statistics for this old partition will become stale right away. So that stats need to be recollected or regathered. With incremental staleness, by default 10%, this existing previous partition could change more than 10% with DML and still will be considered as okay. And you can even tweak the staleness if you need to. There may be situations, depending also on the spread of data and the number of rows in your partitions. You could tweak the stale percentage. Here in this example, we set it to 15%. By default, it's 10%. But be aware, you need to enable the incremental staleness. It's not on by default. When you upgrade now to 19C, the same would apply to 12.2.1 and 18, but we talk about upgrades to 19C because this is the release you all need to upgrade to. Then we have now the new, highly efficient hyper-log-log algorithm. And hyper-log-log is not an invention from Oracle. It's a known algorithm. If you download the slides as PDF, the link will get you to a Wikipedia entry explaining the algorithm a bit more. And with that algorithm, the synopsis shrinks significantly. From the tests I've done and what we've seen, we would estimate between factor of 10 to factors of 25. So let's assume we had a terabyte synopsis before, then it makes a huge difference if you have now just 100 gigabyte consuming than a terabyte before. And it can be even less than that. That is available since 12.2.1. And actually there are two behaviors. First behavior is, and this is the default, the coexistence of old and new synopsis. That means, let's say you have 10 partitions, you upgrade now, and after upgrade, you add an 11th partition, then the 10 existing one will keep the old synopsis format, while the 11th one after upgrade gets synopsis created with the hyper-log-log algorithm. This sounds nice at first, but we are not convinced here that this is the best idea. The other option is regathering the synopsis. And this is what we think is much, much better. And I tell you why. So we want to replace the old with the new synopsis. So in the middle of the slide, you see we have a partition table. The table is called orders. We have a partition. And the idea is now, it has old synopsis format. We upgrade. And then after upgrade, we enforce now the recreation of the synopsis. This, of course, is costly in terms of not cost for license cost. This is an enterprise edition feature, but in terms of performance, in terms of also effort, because if you have like 60,000 partitions, it may take a little bit, but trust us, it's worth the effort. Really it is. What you need to do, you drop the old synopsis. So first call here on the slide, dbms stats, delete table stats, stat category synopsis. Don't delete all your stats, but delete the synopsis. Then you choose the hyperlock algorithm as standard. And you do this with set table prefs, approximate NDV algorithm, approximate number of distinct values algorithm, hyperlock. Now you turn on hyperlock. And then you disallow the coexistence of all the new and you force a regathering and you set the table prefs to incremental stainless null. Change it later on again, once it's done. But this way you force the database now to tell it, okay, these statistics are outdated, you need to regather it. And then you get the new ones. Why are we recommending that? We learn from customer cases when we have the coexistence of old and new, that especially index stats gathering is not good anymore. It's not precise, it leads to a lot of issues. And this is why we came to the conclusion with the customers we worked with that you have to wipe out the old synopsis and you have to enforce the regeneration. Then you need less space afterwards, significantly less space. In that customer case, we really went down from 1.2 terabyte to less than 150 gigabytes, significantly space saving. And it's really way more efficient. So do this, even though it's a little bit extra effort.
Thanks, Mike. Next up, performance stability prescription. This is the workflow that we recommend that you use for your upgrade or migration project to ensure that you avoid as many nasty issues as possible. First, we need to capture your workload information, your SQLs, and your execution plans, so we can keep them safe and use them later on in the process. And we use SQL tuning sets for that. SQL tuning sets is a way that we can take your SQL statements and all related metadata and put it into a single object that we can use as input to other advisors like SQL Performance Analyzer, SQL Tuning Advisor, or the Access Advisor. In addition to that, SQL tuning sets is something that we can transport from one database to the other. So if you migrate, we can take them from your old source system into the new target database, or you can take it from a test system into a production database. In a SQL tuning set, we have the statement itself. Select something from a table. In addition, we have context information, which is the parsing and executing schema. What are the bind variables that was used in the statement? And environment information like NLS settings. In addition, we have execution statistics, CPU time, elapsed time, buffer gets, disk reads, rows processed, optimizer cost, and so forth. And last, but very important, we have the execution plan itself. Take the statement and the metadata, put it in a related object, and store it in a SQL tuning set. You create a SQL tuning set by giving it a name. Next, we need to capture statements from AWR and put it into the SQL tuning set. In this example, I'm looking at the entire AWR minimum and maximum snap ID. I use that as input to the next procedure, which looks in the AWR, orders all the statements by elapsed time, removes those that are executed by sys, and then take the first 5,000 hits. And we then take those 5,000 statements, plans, and execution statistics, and so forth, and load them into my SQL tuning set. In addition, and very important in OLTP systems, you have a lot of small statements that never make it into the AWR, but they might be very critical to your system. So in order to capture those statements, we can be pulling or sampling the cursor cache. What you do is that you start the sampling, then start your workload, and the polling procedure or sampling procedure will constantly look in the cursor cache for new statements and put those into the SQL tuning set. Now, be advised, this procedure does put some load on your system. So adjust the repeat interval to something that doesn't affect your system too much. In this example, I'm sampling for 15 minutes and I do it every minute. Now that we've taken all our important statements and put it into a SQL tuning set, we can now pack it into a staging table so we can transport it. So we extract all the information from the data dictionary, put it into a transportable format, and store it in a single table, a single staging table. If you are going from non-CDB to PDB or between PDBs, you might have to remap the DB ID. And then you can export the table. It's a regular heap table with data pump. Then on your target database, again, you use data pump to import the table, and then you unpack the transportable format into the data dictionary format. And now your SQL tuning set is in another database. Now you have access to those statements and those good execution plans in your new database. SQL tuning sets are part of Enterprise Edition. You access SQL tuning sets via the package DBMS SQL set, but it was added in database 18C. In lower releases, you can still use SQL tuning sets, but you have to use the package DBMS SQL tune. Now, normally that package is licensed in the tuning pack, but you are allowed to use a subset of the functionality with your Enterprise Edition license. But we are not license experts, we're not sales people, so you should always consult your database license information for specific information to your release.
Of course, the only reason to collect that data is to put it to use. So let's start by taking a look at a way that you can hone in on the areas that you need to analyze when it comes to your system performance. What we're going to do is we're going to use an AWR diff report, which, just like a Unix diff command, is going to compare two different entities. In this case, the AWR reports that represent two different execution periods for your system or systems. The way you do this is you take one set of AWR snapshots to produce a reporting period, you make some sort of change, and then you produce another set of snapshots, and then you can compare them. Pretty simple. So the first thing you get out of this using the AWR diff report SQL script is the overall header, which gives you a summary of the execution periods, the timelines involved. It's important to look at that. There's a little tip here that keeping straight which is the first and the second period in the diff report is, of course, going to be crucial to getting a good analysis out of it. So it'll tell you what your configurations were on the system. That could be useful, for example, if you're going to compare performance on, say, a large SMP box versus a cluster of commodity blades or something like that, or even just going to new hardware or non-Exadata to Exadata. A lot of uses for this kind of diff report. And here's an example of diff report from an actual customer case that shows you the value of it. In this case, the customer had done all their testing in UAT, user acceptance test. Everything was running fine. And then they performed testing in their actual production hardware just before they went live. And they found their production hardware, it wasn't running nearly as well. The performance was far below what they had experienced in test on identical hardware. Now, normally we're thinking, I got it. It's got to be that optimizer. It's always the optimizer's fault, right? Well, not so fast, because in this case, what we see when we compare the first, which was the UAT case, and the second, which is the production hardware case where performance isn't good, is you'll notice that it's got this wait event showing up, NQSS contention. Now, if you're like me, I didn't know what that meant when I initially saw this, and we looked in my Oracle support and found out that SS contention, that's for sort segment contention. In other words, it's got contention on the temp file. Turned out the root cause here had nothing to do with the optimizer. It was that their storage was misconfigured on their newly deployed production system. Can you imagine how much time you would have wasted looking for optimizer issues or query plan changes when none of that applied here? The diff report lets you hone in on the right area very quickly. So once you have that kind of information, then we can go into a deeper analysis of it, and I'll let Mike walk you through that process.
Thank you, Roy. I will go on to the next step in our workflow, analyze. So let's analyze our statements now with SQL Performance Analyzer. And the data sheet for SQL Performance Analyzer tells you SPA provides fine-grained assessment of environment changes on SQL execution and statistics. By running the SQL statements in isolation, that means it's a test execution mode, a sandbox mode, and serially, one after another, in before change and after change environments. So we have the information from before, and now we want to simulate after change, after upgrade, but it could also be after patching or after changing the optimizer mode parameter from all rows to first rows 100. So SPA is not only focused on use it for upgrades and migrations. You can use it, and actually we try to educate customers when they have the license, because it's extra licensable functionality, when they have the license to use it basically as a standard tool, even when you roll out application changes. Extra license, keyword, yes, and it's not the cheapest option we have, but what's really cool is you can use that in the cloud, in most cloud deployments. So as we explained before already, have a hybrid data guard, build up a test environment in the cloud, use SPA there, and once you're done with your testing, burn it down and implement the changes, the learnings on on-prem environments. So even if you don't have it, the cloud here is really a good way of using the feature. Let me explain it. In this case, we have a 11.204 environment. And what we do is, or what we did already in our workflow, we created a SQL tuning set with the production workload. So that SQL tuning set has now our SQL, our execution statistics, our binds, all we need, and the plans. We upgrade our test system, and if you go to a new operating system platform with a migration and you don't upgrade, then make sure you export the SQL tuning set in a staging table and you move it to your migrated system. So now we are there. We have all that information in the SQL tuning set. And what do we do with this SQL tuning set? After upgrade, after change, we give it to the SQL Performance Analyzer. And the SQL Performance Analyzer does now a test execution. It simulates these statements. Very important, it's a simulation. It's non-destructive. We can repeat this now 1,000 times if we want to. If you want to test all init Aura parameters through, feel free. This feature allows you doing that. So we have now before upgrade, after upgrade, and we have now several categories like elapsed time, CPU time, buffer gets, discrete, and so on. And we have the plans from before and the simulation after. So what do we do with that information? We compare. And for comparison, we have regressed reports. There are other reports available as well, but I personally find the regressed reports the most helpful ones because I have my regress statements. I'm happy if 10,000 of my statements perform better than before, but I'm interested in these 5 mean guys who misbehave. And we want to identify them, of course, before we go live. This is the idea. So you see in the middle of the slide, 2 columns, trial 1 and trial 2. In my case, the trial 1 is not really a trial because this is what I collected already on production. This is the live information from my production. And now SQL Performance Analyzer went in and did a simulation of that load. And this is trial 2. So I have only the misbehaving statements in that report, and it's expected that they are worse now in trial 2 than they were with the recording on the live system. So you have our categories here, like the net impact on a statement basis. How bad is it compared to the live one? If I click now on the SQL ID of that statement, a C_set_set_1, I get the statement in clear text. In the middle of the screenshot, you see also the execution frequency. This gives you a good indication how often the statement is executed while you captured it on the live system. You see the categories like elapsed time, CPU, and buffer gets. You see the arrow going down. That means it's worse than before. Parsing in 19C increased a little bit, not significantly here. User IO is the same. So, okay, what do I do with that information now? Let's go a step forward. In the same report, when we scroll down, we would see also the plan changes, because when you look at the very right side to the column new plan, you see a yes. So it got also a new plan. So maybe this is the reason for the change here. I see in the same report, plan before, plan after. But we can use that. Let's say we find a way to fix that, or we have a different idea. We'll show you what we think, how you fix this. But we can continuously use that feature, the SQL Performance Analyzer, because what we do now as next thing is we do a change, and it could be anything. It could be an init order parameter, SQL performance, SQL plan management, whatever, doesn't matter. We revisit it again. So we implement the change, whatever that is. And then we do another test run with SPA. And then we get the results for the second test run, and we compare again. And this is something actually I did together with an ACS consultant a long time ago, when we want to see different init order parameters and their effects. So we really went in and we tested optimizer mode first rows 10, first rows 100, and so on, versus all rows. We tested tweaks on optimizer index cost adjust because it had a strange value. We tested really in 10% steps what the effect on the workload is. Of course, this makes only a lot of sense when you have comparable workloads and representative workloads. But it's such an ease. And honestly, if you involve me in your reference project and you tell me we have a license for SQL Performance Analyzer, or we have a test deployment in the cloud where we can test with, I'm really absolutely happy then, because this eases our life a lot in testing, and it eases your life a lot as well, because we can mitigate the risk significantly with that. And it's easy. So with the new results here, we can go back to our regressed report and then here, fix the plan change. Let's fix that.
Now that we have identified the regressed statements, let's look at how we can improve them and come up with a better plan. We will use the SQL Tuning Advisor for that. It's part of the tuning pack, and it's a way that you can get the database to come up with recommendations that can improve your SQLs. Recommendations on statistics are often fairly safe to implement because good and accurate statistics are a good thing. The SQL Tuning Advisor can also recommend creating indexes, materialized views, or change to partitioning. This you should be a little more careful with, because if you add an index, other SQLs will be affected by that index and your DML as well. SQL Tuning Advisor can also recommend you to rewrite an SQL, but it might be a little hard to achieve because it often requires application changes. It can also come up with suggestions to creating SQL profiles, and that I would like to show you a little more about. SQL profile is basically some auxiliary statistics that you can apply to a SQL statement. And the idea is that those extra statistics can ensure that the optimizer comes up with better cardinality estimates and eventually come out with a better plan. SQL profiles are part of the tuning pack. But if your database is in OCI and you're using one of the Enterprise Edition offerings on DBCS or XSCS, it's actually part of the license. The profile itself is stored in an internal format in the data dictionary. It's kind of a black box, so you can't really see how it's implemented. You just need to know that it works. One of the good things about SQL profiles is that it affects one statement only. Only your specific SQL will be affected by the profile. You can enable or disable a profile at will, so it's very useful for testing. And a SQL profile is completely transparent to the application. So you can create profiles on the database while the application is totally unaware of it. SQL profiles are persistent, they survive a database restart, and you can transport them from one system to another. You can create a good profile for your problematic statement in one place and transport it into your production database. And SQL profiles are also very useful if your application is using literals and not binds, because SQL profiles has the false match option that you can set to true. In that case, the database or the SQL profile will remove the literal information from your statement and replace it with placeholders. So two different statements with literals will still match and the same profile will be used for both. It's very easy and very safe to test your SQL profiles. When you create a SQL profile, you can first assign it to a category. This category means that only sessions that belong to that same category will use the profile. So in your test session, you can set the category that you apply to your profile, and then you can do tests to ensure that the optimizer behaves in a way that you expect, that you come out or that you get a good plan. When you're happy with the profile, you can change the category to default, and now all sessions in the database will use the SQL profile. I know that you, Roy, worked a lot with SQL profiles and that you have prepared a real-life example for us today. So will you show it to us?
Sure, Daniel, because a concrete example always helps crystallize these thoughts in our minds going forward. We have a process for using the SQL Tuning Advisor, and I've done this with customers. It's actually pretty simple. The first thing, of course, is we have a piece of SQL that we want to tune. In this case, with this customer, it was the import side of an operation where the export only took 1.5 hours, yet the import was taking 2 full days to run. So that's clearly a problem that we want to address. We went to the AWR report and found the high load SQL, in this case, looking at the elapsed time section. And that particular SQL statement identified by that SQL ID was not really complex. So this doesn't look like it's a case where maybe the optimizer can't figure things out. There's probably something else at play. Running the SQL Tuning Advisor itself couldn't be simpler. You just go to the SQL Tuning Guide and copy and paste one of the examples, plug in the SQL ID in which you're interested, and away you go. It runs in a matter of seconds or minutes, depending on how complex your query is, and it will then produce a report. The top of the report, of course, is just boilerplate. It's your SQL statement, the bind values used, and then you get to the findings. In this case, we had 8 findings, which fell into 4 different classes. The first type of finding, which you see here, is it's a statistics finding, telling you to gather statistics on certain tables in the database. And this can happen if you've got maybe locked statistics that are out of date or simply haven't been refreshing the statistics fast enough. The second type of finding was one of those SQL profiles that Daniel talked about, and it's promising a 2/3 speed up in performance here, and that's pretty good. But even better promises are made for this index finding. It's saying if we create this index on the table, it will speed up performance by 88%. Now that's really good, but look at the rationale section and pay attention to the caution there. Whenever the SQL Tuning Advisor recommends an index or a partitioning or a materialized view, you really need to do that only when you've run a workload through the Access Advisor. And that's because any one of those kind of operations, such as an index, can have implications far beyond the single SQL statement that we're tuning in this run of the SQL Tuning Advisor. So I'm probably not going to take this particular recommendation just on one Tuning Advisor run. The fourth type of finding that could happen is that the SQL Tuning Advisor will look back into your AWR and see whether you've run this same statement in the past, but run it much faster. Now, it does a lot more than just look at whether it was fast. In this case, you can see that the 5 times it found this statement running before, it couldn't reproduce the conditions that were used for the plan in place there. Now, whether that is something about the number of rows in the table or other database conditions, you don't know. But the fact is, in this case, it could not find an alternate plan that was better. So what do we do based on all of that? Well, the first thing I always do is follow any of the stats gathering recommendations, because it's always good to have good stats in your database. And what we found in this case is that when we gathered stats on those 5 tables, it improved our performance by a factor of 20. And we didn't need the profile. We didn't need that index. So that's the kind of approach you can follow, where this whole process could take you in this case, less than half an hour, from finding the statement to running the tuning advisor to getting these results. And that's a really good way to go about tuning the SQL in your database. But it's not the only way. So I'll let Mike tell you about another approach.
And if nothing helps, select star from I am slow. What could you do? There's one additional feature, which interestingly enough is available on Enterprise and Standard Edition too, and this is called SQL Patch. So the idea of SQL Patch is that we repair a misbehaving statement by adding hints or ignoring existing hints. And this is all in a procedure. So this is fully transparent, no application change required if you use SQL Patch. It's persistent, so it stays in the database, and if you want to transport a SQL patch from A to B, you do this with a script. It got introduced in 11G and made publicly available and documented as well in 12.2. So I won't focus on the left side because this is the 11.2 and 12.1 code with an internal package. But on the right side, dbms SQL diag, this is the package we are using here. And here I'm using a simple SQL text, select star from big table, and I add a parallel hint to it. So whenever this SQL will identify itself with the SQL ID, and certainly as we wrote in the pro tip here, you can use, of course, also the SQL ID instead of the real text, then this hint will be applied. Or in reverse, if the hint would be embedded, we can simply ignore the hint for that statement. We have also a demo for that, but here we would guide you to our YouTube channel for the SQL Patch demo. And what we're doing is basically a statement has a hint, and we ignore that hint with a SQL patch and make the statement run twice as fast as before.
Now that we've found the regress plans, we tuned them, it's time to ensure that that specific good plan is always used for your SQL. And this is where SQL plan management comes into play. The idea with SQL plan management is to ensure that only good, validated plans are used for your SQLs. So we avoid a situation where a SQL is suddenly regressing due to a worse plan. So how does it work? Your users are connected to the database and they're issuing SQLs. The second time the same SQL is executed, it's called a repeatable SQL. When the parameter optimizer capture SQL plan baselines is set to true, whenever you have a repeatable SQL, SQL plan management will record it. But first, it'll run it through a filter so you can decide whether or not you want to capture that plan. You can provide a filter on this statement or on this schema. The optimizer comes up with a plan. We call it plan A. Because this is the first time that this specific SQL is executed, there is no baseline. So SQL plan management creates one and it adds the plan to the baseline as an accepted plan. Plans are only added to the baseline as accepted when they are the first one. Next execution. Something has changed. The optimizer has come up with a new plan. We call it plan B. What happens? The plan is moved into the plan history. Plan history is a dedicated part of the plan baseline, which contains known plans that have not been validated yet. We don't know if that plan is good or not. So we keep it in the plan history. If you set optimizer use SQL plan baselines to true, SQL plan management will now tell the optimizer, you cannot use this plan. It hasn't been accepted yet. So plan B stays in the plan history. Optimizer discards plan B and uses plan A instead. The plans in your plan history can be enabled or disabled. This is a quick way where you can selectively enable or disable specific plans. A plan can also be accepted, meaning that we have verified that this is a good plan that performs well. And you can also fix plans. If you fix a plan, it'll take precedence over accepted plans. So this is a way that you can manually assure that one specific plan is used for this SQL. We'll talk about evolving in a little while, but you should know that on plans, you can change the auto purge property from true to false. If you change auto purge to false, a plan will never be purged from the plan baseline, regardless of whether it's used or not. Now we need to talk about evolving. Imagine our users have been using the database for a while, and for one specific SQL, we now have multiple plans in the plan history. We need to find out whether those plans are actually good or not. And we do that by doing a test execution. So for each of the plans in the plan history, it'll do a test execution. And if it finds out that the plan is not good, it'll keep it in the plan history and check the other plan. And in this case, the test execution actually finds out that this is a good plan. It performs better than the other plans. So it moves the plan from the plan history into the plan baseline and mark it as an accepted plan. So the next time you execute an SQL, this plan can be used by the optimizer. Evolving takes place in your maintenance window, and it's part of the automatic SQL tuning task. By default, plans that have been verified by the evolve task to perform better will be automatically accepted, but you can change the behavior if you want. And it's also possible that you manually can perform the evolution. All this information is stored in the SQL management base, which is stored in your sysocs tablespace. In the SQL management base, you will also find profiles and patches and so forth. Information about the plans is stored in a lob segment, and I'll come back in a little while to why that might be interesting to know. If a plan hasn't been used for 53 weeks for more than a year, it'll be purged from the plan baseline. And the budget, the space budget of the SQL management base is set to 10% of the sysocs space. You can use DBA SQL Management Config View to check the settings of SQL Plan Management. My recommendation is that you change the retention from 53 weeks to 5 weeks. Having stored all plans for more than a year, I find is too much. Most plans, if they haven't been used within a month, chances are they won't be used at all. If you have a quarterly workload or a yearly workload with some very specific SQLs that you want to ensure are always performing good, you can either change the auto purge property on those plans, or you can fix the plans to ensure that they are always used. I would prefer that over having a retention of 53 weeks. In addition, you should lower the space budget percent from 10 to 5. Please note, and this is very important, this is not a hard limit. When you go across the limit, you only get a message in the alert log. It's not a hard limit. And I told you previously that all this information is stored in a lob segment. So imagine that this runs wild and fills up your sysocs tablespace. Now you have a huge lob segment that you have to get rid of as well, which might be a little tricky. Now, let's look at how we can load more plans into the SQL plan baselines. Because previously, in our source database, we collected all those good plans and put them into a SQL tuning set. Now, we can take the plans from the SQL tuning set, put them into the baseline, and because it is plans that you provide, the database assumes that it's a good plan and it's automatically accepted. What if you have literals? SQL Plan Management and an application that uses literals is really not a good fit because you simply get too many distinct statements. Could you set cursor sharing equals false? No. I won't try to describe it because if you follow the link in the slides, the real-world performance team has some really good arguments as to why this is not a good idea. If you have literals, SQL profiles is the option you can do because it has false matching. But really the optimal solution is to change your application to use binds. not only will it make SQL plan management work, it'll also make a lot of other good things to your database. Now, a use case for upgrade and migrations and SQL plan management. In this situation, we have our source database running on 11.204, and I capture all my good plans into a SQL tuning set. In my test database, I identify the regress statements and I tune it and come up with good plans, and I put those in my SQL tuning set as well. I then load plans from the SQL tuning set into my production database, and I can do it very selectively. I can specify one specific SQL ID and one plan hash value and only load that specific plan into my baseline. This is a really good use case to ensure plan stability. But finally, let's compare the options that we have to ensure plan stability: SQL plan management, SQL profiles, and SQL patches. Now, the interesting parts, I think, are the last two rows. First, plan guarantee. SQL plan management is the only option you have that will guarantee you that only one specific plan is used for your SQL. In addition, if you look at the maintenance row, the last row, you will see that with SQL plan management, you can do automatic evolve. You can let the database test execute the new plans and only use those that are found to be better. Whereas with profiles and patches, you, over time, has to manually inspect your profile and patch to determine whether or not they are still suitable for that specific SQL. If you all of a sudden load 10x the amount of data into that table, you might have to revisit your profile and patch to ensure that they are still fit for that statement.
So as the last part of our performance prescription, we will now test and verify our changes. And here we will utilize database replay. The idea of database replay is we capture a workload on production and we replay it with the right timings, concurrency, and transaction characteristics on a test system. That's important because a replay is destructive. And this requires also real application testing. This is how it works. Here in my example, we have an 11.204 database and we start a capture. At the beginning, take like 30 minutes for a start. We get capture files and we move them over to our test environment. In the test environment, we will now pre-process these files. And pre-process means they get like translated. Then we will execute a function checking how many replay clients we will need to start. And once we started a replay clients, the replay clients will now execute the translated files and send the transactions to our database. At the end, we do a replay analysis. And here we borrowed screenshots from my colleague Ulrike from German pre-sales. You get some overview figures. How long did you capture? How long did it take to replay? But more important, and I advance now, once forward, we look for replay divergence. So in the upper part of the screenshot, you see the replay divergence is high. That means either some of our application calls failed or the result sets were different. So what we do when you do a select star from emp, we record 14 rows, but not the 14 rows actually. We record that we got 14 rows back. And when we replay, we compare now. So it's really key for database replay that your replay system where you execute the replay has the same characteristics and especially the same as CN. So this is platform independent, very important. You capture on AIX, you replay on Linux, no problem at all, no restrictions. It's RUG compliant. You can do this also within a PDB and replay in a PDB since 19C. And you can, of course, capture and replay across different releases. A few things to consider. The workload capture has some restrictions. Some things aren't captured. And it's not suitable as soon as you have a lot of external dependencies, like tons of database links or external tables, util HTTP, and some other restrictions. Plus, it's ideal when you restart the database. So in an ideal scenario, before you start your capture, you bring down your database, then you start it up restricted, and as soon as you start the capture, it opens the database unrestricted, and then the application calls can come in. This way, the capture makes sure that no transactions are caught in the fly and need to be like figured out or rolled back or whatever. And it works best from a dedicated SCN. When you do this with the capture tells you the SCN. Ideally, your replay system can be put exactly on that SCN before you kick off the replay. Now, in summary, this is our performance stability prescription. You collect plans, for sure, because this can be your lifesaver. Then we do AWR diff reports, we compare. In the third step, we use SQL Performance Analyzer to find the misbehaving statements or to optimize our system. Then we used SQL Tuning Advisor and SQL Patch to tune the system. And we enforced plan stability with SQL Plan Management in step number 5. Finally, in step 6, we verified our tuning efforts with database replay. And this way, we are pretty certain that you can ensure plan stability, performance stability when you move to a new environment, even for a migration.
Okay, so let's take a quick spin through some of the things that you might not have noticed in 19C and some of the underscore parameters that might be useful to you. First is this feature called Automatic SQL Plan Management, which, like its name implies, takes that SQL Plan Management feature that's so useful and automates it further. It will run every night during your maintenance window on Exadata systems, and you could enable this on non-Exadata systems if you want to. There's a lot of control that you have over how often it will run or what kinds of statements it will try to tune and whether it will accept plans automatically. So we would really encourage you to look into this to decide whether you want it running on your system. Automatic SQL tuning sets were something that were implemented for 19C, but they've been disabled by default since 19.8. The reason for that is that while it's a nice idea to always have SQL tuning sets available for performance analysis, some customers find that this is causing their sysocs table space to grow much faster than they would like to see. And as sysocs grows, you can never shrink it again. So if you are 19.7 or earlier and want to disable automatic SQL tuning sets, there's a way to do that manually using the Auto Task Admin interface. 19.8 or later, if you want to enable it, you could do that as well. Adaptive features in 12.102 were probably the biggest performance issue we had in 12.102, but they've been basically fixed for 12.2 and beyond. And that was done by splitting the optimizer adaptive features parameter into adaptive plans and statistics. Now, plans are going to be on by default because most customers had really good results from optimizer adaptive plans. They help you adapt to changing workload conditions. Adaptive statistics are where the problems came in, and those are off by default. So our advice for this area of optimizer adaptive features is to just accept the defaults starting in 12.2 and going forward. But related to that is this underscore parameter SQL Plan Directive Management Control. With those adaptive statistics disabled, you might think that SQL plan directives weren't being created because you're not going to use them. However, the default is still to create those plan directives just in case you want to use them in the future. So if you're not going to use adaptive statistics, which is going to be the case for most customers, then we would advise you to set SQL Plan Directive Management Control to 0 and prevent the creation of those plan directives. Cursor obsolete threshold, this is an underscore parameter that had its default value change in 12.2. And frankly, the old value is perfectly fine and much better for most cases. So instead of the new default of 8192, we would advise most people to set cursor obsolete threshold back to 1024 unless you have a very highly consolidated multi-tenant environment with dozens or maybe hundreds of pluggable databases. Optimizer real-time statistics. This is a new feature in 19C, and it's an Exadata-only feature. What it does is it gathers basic statistics when you're performing DMLs, such as inserts, updates, deletes, and data loads. The problem is that it can use a lot of resources if you're performing, say, a highly parallel data pump import, and you may or may not want it enabled all the time, even on an Exadata system. Now, up until 19.9, this was on by default, and it was controlled only by underscore parameters that you see on this slide. Starting in 19.10, even on Exadata, this is disabled by default, but you can turn it on if you want it, such as if you find that you need to have statistics gathered more frequently during the day, but you just don't have time to have extra maintenance windows. Finally, deferred segment creation. This is an 11.201 behavior that was turned on by default and it was really targeted for these enterprise applications like SAP, EBS that create thousands of tables that might never be used. The idea behind this is that when we create a table, we don't allocate a storage segment until you actually insert into it. So it can save you space and not have extra orphan storage segments around your database for those unused tables. The problem is that there have been maybe 36 or so serious bugs with this feature over the years. And in fact, there's even one still open on 19.10. So for most customers, unless your application tells you specifically to turn deferred segment creation on, we would recommend that you set this parameter to false. Okay, that's a really quick spin through some of those little secrets and parameters that you can use to help your database run well. That basically finishes our tuning talk, but there's one more case that you should really think about if you are running standard edition.
Thank you, Roy. Yeah, so what if you are on standard edition too? A lot of the things we showed are on enterprise edition, or a few are even extra licensable. But just in case you're on SE2, there's still a big variety of excellent tuning tools out there. For instance, Modes or Tunnel Porter Snapper, SQLDB 360, where the screenshot here is from, done by Carlos Sierra and Mauro Pagano, and Mauro's tools, Tuna S360 and Pathfinder, which are very, very useful. Not only on SE2, also on Enterprise Edition, by the way, but most of these tools you can easily use on Standard Edition. Never forget, there's still event 10,046. That's SQL Trace, which traces everything, including the recursive statements. So see this Moz node for more information. And just finally here, SQL Plan Management. A portion of SQL Plan Management is even available in Standard Edition too. So please check the license guide, because there are some restrictions, such as only one SQL Plan baseline per SQL statement and a few others. But parts of that is there. And so now it's time to take a deep breath and relax.
Oof, well, that was a very full 2 hours. Thank you for attending today. If you made it this far, we're pretty certain that you enjoyed the seminar and you're now inspired to take your next upgrade or migration project and make it not just successful, but even easier than it's ever been before.
Next time, we will talk about multi-tenant and how we can migrate into this new architecture. And I promise you, it'll be just as fun as today.
We will hang around a little while in the chat, and we will try to answer all your remaining questions. So hope to see you soon again in our next seminar. And until then, happy and successful tuning. Thank you.